So let's get that off grounded and that falling logic for this. Okay, so basically the trick is to know when we are going to be switching from the NavMesh agent moving to the physics moving, so we can fall off ledges and so on and so on. Okay, let's go on to our move player character, and we do have the logic for move with physics, but since it's kind of very similar to moving with the agent, as we see, let's see, as we see inside the execute. Well, okay, it's a little bit differently. Now, because we are going to be moving, for the most part, we're going to be moving with the NavMesh agent, I think the angle detections and stuff like that, we won't really be needing them for just assigning the velocity onto our character in this case. So we can simplify this a lot more. First of all, let's assign. Okay, let's assign. I think we have already assigned it. State is grounded or not. So if you're not grounded, then take the velocity you have. Well, first of all, make the rigid body to have the properties we need, and assign that velocity as your target velocity. Okay, so checking now from where the is grounded is turned off, and let's see. Yeah, it's always turned off. We haven't yet done the grounded behavior, which means if we switch this now onto play and I go and untick this grounded or not, okay, I'm moving. Normally, if I untick this, I stop moving. I stop moving because, let's see, our rigid body is kinematic. Because NavMesh agent is on, that's why we stop moving. There is a few slight differences that are happening. And also because we are moving with, I think with late update, I think there is a little bit of a jerkiness over there. So let's find it back. Okay, so that's how we're going to play with this. Obviously, we need to do some slight changes and enable and disable the NavMesh agent when we don't want this, when we don't like that behavior. So let's see what we'll be doing. So instead of, actually, let's just copy this and say that if you are grounded, then is kinematic is going to be true, but first check what state it is. We don't want this to be happening all the time. So if it's false, set it to true, and the opposite to here. If it's true, set it to false. So we can be moving around. The other thing that we need to be doing is if states.agent is active and enabled, states.agent enabled equals false. And similar to this, copy that. Once we are on grounded, and before you add the velocity on the agent, we need to make sure that is an actual active agent. Okay. So now let's start checking for if you're grounded or not. Let's close all of this. And what we should do is create a method for check ground. Obviously, we're going to be doing a raycast down, raycast hit. Let's say vector 3 origin position on that origin. Add some slight offset, maybe 0.1f. Okay, direction will be down, so we don't need that, and we can do physics dot raycast origin vector 3 down, out hit for about, I think even 0.5 should be enough. And if we have a layer, we can also add this. Yeah, okay. So if we hit ground, we're going to be getting a value. And let's see, vector 3, target position will be hit.point. Then we need to check if that value is inside the NavMesh. And the way to do that will be from Unity Engine .ai, and we can now access the NavMesh let's see, is it sample position? Yeah, sample position. Yeah, okay. So we need to have the NavMesh hit. Actually, I think we don't need to have the NavMesh hit because we're not really going to be doing anything with that. NavMesh hit, nav hit. So sample position, target position, out, NavMesh hit. Maximal distance, that depends on how far you want to take this. Okay, so I'm just going to do maybe 0.2 f. We like to be pretty accurate, and we don't want, let's see, yeah, we need to pass an area mask, and I think if we pass 0, it will just cast it on all positions. So I don't know if we can use this as an if, and we can, yeah, it's a bool. So if this is true, then states.grounded equals true. Otherwise, states is grounded equals false. Otherwise, states is grounded equals false. So check for ground. When we're executing this, let's do it the first thing we do. So we're checking for the ground. We are moving on, yeah, we're basically moving with our velocity on the agent when we're on the ground, and when we are not on the ground, we are just assigning the target velocity, but on that target velocity, the .y will be whatever you have on your rigid body already. So it's going to be gaining .velocity .y. So it's going to be gaining, you know, speed and velocity on the y-axis if you're falling down. Okay, so let's do a debug.drawArray here, just so that we know what we're doing. Let's make it red. Okay, let's start with this. Let's turn on gizmos, and now you can see that it's grounded, and if it's grounded and if it's not grounded. But we do kind of have some small issue. The hit position, it's not registering as, actually, let's see if it was from that. Yeah, okay. So we need to raise this value. Let's set it to 1, although I think 1 will be too much. Let's set it to 0.5. I think it has to take into account the offset you have from your NavMesh as well. Yeah, I think it's just too small. let's set this to 1 then. Or let's go on the player state manager and let's change it from here. Let's say NavMesh detect distance. Let's set it to 1, and then on your move player character, or it could be the, yeah, I think it might be this as well. State NavMesh detect distance, and actually let me check, and this needs to be navmesh.allAreas actually. Yeah, instead of 0 it should have been -1, I guess. Okay, let's try this, and then we can play with the values we've added. Let's compile. Okay, so we have this running. Let's try the values. Let's set it is to 0.2, and it works fine. We are grounded or not. Let's now go up the stairs. Okay, so right off the bat you'll see that we do not take into account if you are going to walk off of the ledge or whatever, because the NavMesh is pretty much over there. So you'll see that you just need a slight half a point forward and we will fall off the ground. It will switch to that. So to change that, to fix it, we can also assign on the origin, we can pass a direction for where we want to go. So let's move this below there, and we're going to add, actually we already have the target direction, so you know what, let's copy that. Do we though? No, let's use the velocity from this. So this will be our target velocity, and on our origin we're also going to add the velocity we have. So now it will be moving forward based, and it's going to be looking towards where you want to look, where you want to go, rather than where you're going. Now this can be a little bit tricky because now I'm outside of this grounded, because it's moving inside the angle. So to see it a little bit better, I'm going to go, actually we don't need to go over there, it's in the inspector, and you will see that the red line for the is grounded or not is going to move inside the slope, so it's going to take it like you're not actually grounded. Oops, I missed that. Okay, you see that that's why we're going like that. So to fix that, we can raise this, let's say to 0.5 and to 0.1. Also this is to 1. Also we should be doing a raycast forward in case, you know, we hit a wall or something. So I'm going to make this as a reference value. So that means if this target velocity changes inside this method, then that means it's going to be affected from outside of, for the rest of this method. So we do have our raycast hit. Let's do first the raycast hit forward, and then we'll do the raycast hit below. I'm going to duplicate this line, and I'm going to remove this origin. So for this origin dot y, I'm going to add, let's add 0.5 again, I guess. So we don't need that. Okay, but first we're going to do physics raycast origin states mTransform.forward for out hit for about, let's say 0.4 f, and we want to be hitting everything. If you hit something there, and if you hit something straightforward from view, then change the velocity to vector3.0. If you don't, then the velocity will just continue as normal. We do have to replace, I guess we don't have to replace it since it's the same value now. Okay, so now we're doing a raycast forward. States.mTransform forward multiply by 0.4 f, just in case we do not hit a wall or something. Okay, so let's see it again. And you will see that the velocity kind of jumps now, and it jumps a lot. So that means this velocity as a direction is not normalized. So let's take it as a direction. Yeah, it's not normalized, that's why we are missing that. And let's do it like this. Okay. So now we have the direction as well. We already know that we are grounded. Okay, so let's aim towards that. Okay, so depending on the angle you want, it's going to be changing that. And as you saw, I fall down pretty much like that without even noticing a change on the controller. You can try it and you'll see that it's pretty smooth as itself. It might be the cinema scene that is jerking. I think that's the case, but that's easily fixed as well. Okay, and of course we're not going to keep playing the same animation. Okay, so we're going to change something now, and we're going to be seeing first, we're going to want to check if stage dot is grounded. If you're already grounded, then check for this. Actually, this is kind of silly. We don't want this here, we want this down here. So we're going to be checking if stage dot is grounded and you're not hitting something off the ground, then that means, well, that definitely means you're not grounded, but it also means that you're going to be on the air. We need to check now if you're going to be on the air. So on the character state manager, since the enemies are going to be able to fall down as well, we're going to check this to is grounded, is on air. And back to the move player character, is grounded is false, and if stage dot, or actually let's just do it here, I guess. If stage dot is on air equals false, stage dot is on air equals true, but we need to play the falling animation. So let's go and check what happens with our animator. And as you can see, we do not have anything for falling. Let's see what animations do I have here. We do have 2 falls, and I don't even know what this is from. Anyway, let's see. Have air, mid air, I guess. Okay, well, desperate times calls for desperate measures, so we're going to use this for this. So on air, and it's just going to stay here until we touch the ground. So state is on air, state is on air equals true, then that means we can just go onto the animator and say play on air. Obviously, we are doing something wrong here. We need to go through the entire thing that checks if we basically need to change the state in this case. Okay, so let's go and do that. We do not have a state for, actually, you know what, we can just use this, the attack state, and to use that, I guess we can do this. Let's see. Yeah, okay, let's use the same calls. So I'm going to go and find my attack. And yeah, let's see. We do have the item action, attack action, and we're using play target animation. Okay. And that's for the character state manager. Okay, awesome. So play target animation. And I think we shouldn't really worry about anything else since it handles everything. So let's see. Let's see, move player character is grounded or not. States play target animation. Let's say on air, true and false. We don't care. Now, there is one small thing that's going to happen. However, if we're changing the is interacting, we're not actually changing the state in here. We're not really changing the state. So let's see how we're doing this here. Because we are assigning this, I think this changes the state. No, it doesn't. How am I doing it? Well, anyway, let's try this and we'll see. So let's test this. Now, we do not have leave out of the state, however. So we're going to be stuck on just falling. As you see here. Okay, so as far as the controller goes, I'm super happy with this, even though we're sliding now. But if you wanna, I guess if you wanna do a skateboard game, well, you know, at least this moves with a constant velocity. Anyway, so okay, I'm really happy with how the controller is starting to look right now. But we can fix all the issues that appear from the changes of this. So the thing is, we are changing now the logic. Let's go back to the move player, however, and we're going to do, if we're hitting now something and we are grounded, we do not care if we are grounded or if we're not grounded in the NavMesh. Okay, we just want to check now if we are on the air or not. So if states.is on air before, then we're not anymore on the air, of course. Then we're going to change this to just the empty, and you know what? This will still be false. However, keep in mind that we might yet not even be playing this logic. We might not even be calling it, I mean, because we are changing the states. It will show now. And actually, we should probably rename this to empty override, but it will work since all the other layers have different name for the empty. Okay, so let's go up. And yeah, obviously you don't have to do the empty. You can just play a land animation depending on the height you dropped, and so on and so on. Okay, so I think I'm super happy with this and how it works, because we are super smooth moving and you can really feel it in the controls. Now, there is a slight things that happen there, because you can see how far away is the check for if you are in the ground or not. So I had some problems with the recording, so anyway, I made it to work. Okay, we can fall down and it works perfectly. There's one small issue now. We can see that the distance for the check, if you are going to fall off the ground or not, is pretty far away from what we need, because we start falling from here. We want to be a little bit more closer. So, to check that, well, first of all, if it's not yet in the video, because of the recording problems, I basically just added only these 3 lines inside the raycast that checks if you are on the ground. We don't really need to check if we are on the NavMesh. At first, we just know that there is a collider below us, and we're hitting that. So, we can add now a multiplier to this for the characters. Let's do this above here, I guess. And we can do public float ground ray forward distance. Okay, we have it at 1 right now, but I think maybe even 0.2f should be enough, because we know we can go at the edge of our NavMesh. Okay, so just go down here and here where we are. The direction we are adding, which is the velocity we're passing based on our inputs, we're simply going to be multiplying, we're multiplying the direction via the states dot ray front ground ray for distance. Okay. So now it should be closer to us, which means it's going to be more precise, more correct. Okay, you can see that it goes much more clearer. And we should be able to fold now. Yeah. So pretty much once we are on the edge. Now, in Dark Souls, you're not actually falling right off when you are off the edge. I'm trying to rotate this. Okay, you're not actually falling there. You do have a little bit more room to move. So instead of a sphere cast, instead of a raycast, it's a sphere cast. Okay, and that will solve this issue as well. So let's go and change that to a sphere cast. Sphere cast. And for the sphere cast, we need to pass the origin, the, let's say, 0.4f for how far for the radius. We have the direction, and everything else should just be the same. Or you know what? Let's maybe make this into public variable, sphere cast radius 0.4. That's not how you write radius. Okay, then back to move player character. On here, states dot spherecast radius. Okay, awesome. So hit play. And that's interesting. I think the 0.4 might be just too much, because it's 0.4, let's say the radius of the agent is 0.5, so that means we're looking, if this is 0.5 of the radius, then that means the this is 0.5, so we're checking double this. So let's make it something even smaller. Let's maybe make it to 0.2 as well. And yeah, that's more accurate still. So going on the edge, as you can see, until we are clear of, actually it doesn't even happen because we are hitting yeah, because we're not actually hitting the velocity and we want, and it still finds the sample position. So I think maybe we should play with that as well. So let's see, NavMesh detect distance. Instead of 1, let's set it to 0.1. And yeah, there it goes. Okay, so now it's a values thing instead of it does clamp the character back from what I can see. That's a small byproduct, it's a small bug, we can fix it, doesn't matter. Because we can just add a delay for when you're going to fall down to avoid this clampness. But I think I like it. I think I like it more with the raycast instead of the sphere cast. Oops. So let's just skip the raycast for now, because it feels slightly more accurate, to be honest, and you know exactly where you're dropping. So let's pause that. Let's change the value from here to 0.1 just to be sure, and hit play. So yeah, I think it just comes down now to, you know, some values, and of course depending what you want to do on your game. Now I'm not entirely sure if we do get the jerkiness from the camera now, from cinema scene I mean. Okay, but let's just say we want to be sure about it. So here's what I'm going to do. I'm going to create a cinema scene hook. Let's go under scripts, under utilities, and I'm going to do cinema scene brain hook. That actually sounded more gruesome than I wanted anyway. Let's open it up. Okay, so, and I think it's R2, yeah. Is it, or we change everything? Yeah, it is. Okay, we don't care about update. We're going to make this as, actually, should the cinema scene have a singleton for that already? Camera actual, oops. Solo camera, can we get this? Let's try and get that, I guess. It tells you this solo camera, okay. And this is under cinema scene. Okay, so under move player character, once you start falling and so on, we can, or once you, yeah, I guess we can just try this. Since it's grounded, it detects if you're moving with physics or with the agent, then we can just use this here. Okay, so if states grounded, then cinema scene brain dot solo camera dot update. No, it's not the update, it's the update method. If we are able to change that, of course. Okay, let's go dive into the code. Update method then. And we can access it. Why though? We can access it because it's... no, why? Let's say tooltip play cinemas brain, creating that. Because it doesn't actually return you, does it? So hold on. So you know what? Let's do the because this actually returns me something different. Oh, it's the or is it the output camera? I guess it's the output camera. Let's see. No. Yeah, this doesn't actually return me what I need. Anyway, so let's do it via the hook. So public cinemascene brain, then public static cinemascene brain hook singleton void awake singleton equals this, and then on start or on awake as well, brain equals get component cinemascene brain and let's do cinemascene first, cinemascene brain. Okay, save that. Then on our move player character we can simply change this to, let's close that, cinemascene hook brain hook singleton dot brain dot update method to late update and on else to fixed update. Awesome. So let's try this, and I think that's the last thing we'll do for this part. And yeah, we forgot to assign the cinemascene brain hook. Cinemascene. Okay. And you can drag and drop this or just let it run, whatever. Okay, and let's try this. Okay, so the only thing that's not that very nice, oops, oh no, okay. The only thing that's not very nice is the missing landing animation, but you know, that's quite kind of part of the job. And here's another thing. Actually, there's one small issue yet again. And to try this, I'm going to move the game scene over here, and I'm going to move the scene over here. And as we're falling, you'll notice that when the NavMesh agent is going to be enabled, down here, notice what will happen to the character. Okay, so it's still not hitting the NavMesh. And the moment it's going to find it, the moment the raycast will say that, you know, I have the ground, it enables the NavMesh agent, which means it clamps it back to the ground. How to fix this? Well, for first, I'm going to try and change the distance we are doing it, or the distance down, I guess, for this. So let's say float distance for down, we have it as 1. But if stage dot is on air, I'm going to change the distance to 0.5, which is the same as the offset we add here. Okay, so distance will be 1, and let's multiply this by the distance. So that means if when you're falling, the change should be, yeah, it shouldn't really be a significant change. It shouldn't really be anything, actually, because it should look almost like touching the edge of your agent. Okay, so let's try and fall once again. Okay, so he's falling. I'm not actually pressing any velocity, that's why he's falling straight down. You can see the distance now is, yeah, we should also take into account the NavMesh detect distance, so we might need to grab that as well. Okay, I think that's far better. That's looking more correct. So let's see it in real time. Okay, there is a small jump that I haven't yet found. I think it's just also that. So let's say maybe change that to 0.1. Yeah, that's too small, definitely. Let's change this to 0.5. Interesting. Yeah, now it kind of went. Now it's not even finding it. So yeah, definitely 0.1. That should stay at 0.1. But yeah, that's not really that much of a problem, since you could always just play a landing animation, especially from high above. Unless it's a cinema scene issue. Let's see. I actually think it's not. So, you know what? Let's do the character state manager. Let's say ground, it's not how you write it down, ground down distance and on air, because once we are on the ground it doesn't matter anymore. So ground down distance on air 0.2, I don't think, let's do 0.4, because +1 it should be the ray detection of player character then. So if this doesn't work, we're going to change it on the next part, and we're actually going to make the character lerp to the position of to the position of the NavMesh agent instead of copying it entirely. So stage dot ground down distance on air. Okay, which I think it's not going to work, but we're going to see it later. Yeah, okay, it does work. It is from there, from what we saw. Now we take distance, and well, actually, as you can see here, what's actually happening is that you do not touch the ground because the collider of this, it's actually stopping you from touching the ground. So it might also be the collider that causes that. So let's try with the collider closed. And the collider, I think, shouldn't really, we might not even need the collider anymore, since the NavMesh agent is what grounds us. Yeah, okay. Doesn't actually, no. Yeah, okay, I think that worked actually. It didn't make him clamp, I think. Well, I can't tell because of the animation, so let's disable the animation for playing the empty. Back again, so we're just going to slide around the first time we fall. Yeah, no, it does clamp. It certainly clamps. And well, it didn't clamp now, I think. Oh, it does clamp. Yeah, okay, so you know what? It's not really that big of a deal because we can, as I said, we can fix that easily. So let's enable this. Let's end this part, and on the next part we are going to move forward, maybe with some other stuff first, and then get back into fixing all those bugs and the clamping issue and so on and so on. It certainly is something we need to take care, get rid of, or maybe let's try playing with this a little bit more, I guess. Let's do 0.45. And yeah, that actually, well, okay, it didn't work because we're still on the air. Yeah, no, you know what? Let's leave it. Let's leave this to 0.5. You can enable or disable the collider, it's up to you. I think well, first of all, we have a little bit of an issue with the collider either way because it's actually going through the ground. So it needs to be raised a little bit upwards for sure. 0.2, no, 0.1. Point 0.5, no. 0.8, I guess it's 0.8. 0.8. That might do it. Still clamps. Anyway, let's leave it at this, and we're going to fix a little bit the grounding issue a little bit later. So you know what to do. As always, like, subscribe, and if you like to see more stuff like this, all these things we're doing in this channel, in this series, and all the other series, then of course consider supporting me on Patreon so we can keep making a lot more of these videos. I'll see you next time.